Okay, so these are inequalities. See, it's got the inequality sign. And then you might notice that what it has that's a little bit more special is that the x is actually on the denominator. So straight away, when you start this, I want you to look at the denominator. And step 1 is to make the denominator not equal to 0, because that's where it will be undefined. So it definitely won't be a solution. So x minus 1 equals 0, so you get x equals 1. Okay, that's stage 1. Okay, the second stage. You make the less than or greater than an equal sign, and you actually just solve the equation. Okay, so let's do that. 8 on x minus 1 equals 2. 8 equals 2, x minus 1. 8 equals 2x minus 2. 10 equals 2x. So x equals 5. So that's the other special solution there. X equals 5. So we're getting there. So we now have x equals 1. Now at x equals 1, that would have to be an open circle. Now why is it actually open? Because at x equals 1, it is undefined because it is on the denominator. So closed circle means it can equal that value, but it can actually never ever equal 1 because x minus 1 would be 0 on the bottom. This here, this is an actual solution, and because it's got a less than or equal to sign, that one would be a coloured in circle because it does actually exist. So put it onto a number line, that's step 3. So what have we got? We've got 1, so go 0. 1 is an open circle. 2, 3, 4, and 5. That one's a closed circle. All right, so the next step here is to test where it is true. So where would it be true? So have a think about that. That would, like if I put in a value, let's put one in that's in between here, say 2. 8 on 2 minus 1 is less than or equal to 2. Then you could go 8 over 1 is less than or equal to 2. Definitely not true in there. So that's a no-go. So if it's not true on the inside, without even doing anything, it should be true on the outside. And then you're just left with writing a solution. So you've got minus infinity up to 1, and it's a curvy one because it's not equal to it. And then you go from 5, which is equal to, so you need one of those brackets, 5 to infinity. And that would be your solution. Okay, now I think I have another one up here to solve. There it is. Okay, so this one is slightly, like a little bit harder. So the first step is you make the denominator equal 0. So x equals 1 because x cannot equal 1. Then you get the inequality and you make it an equal sign. Now when you go to solve that, the x minus 1 is 1 whole bracket, and that's a division there. So when you move it to the other side and you solve it, it's 6 equals x minus 1. Okay, so in order to solve this equation, you need to expand that to get the quadratic. So you get x squared minus x, and bring the 6 to the other side. So it's x squared minus x minus 6. Okay, and the third thing, then you need to actually solve that. So that'll be x minus 3x plus 2 equals 0. So you end up with x is 3 and x is minus 2. So far our special points is, sorry, I meant to get, it's going to be minus 2. Get a highlighter. So we've got x equals 1 is a critical point, and x equals 3 and x equals minus 2. Okay, so draw a number line. So we're going to go with that 0. The most we go down is -2. And I'll put an open circle there. Think about why, because it's not equal to at that point. Okay, so that's -2. And what else? -2, 3, and 1. So that's 1. That's open as well. 2, and then 3. And that's open as well. It would only be closed if up here, if this one here, if that one there was like greater than or equal to, but it's not. Okay, so let's test a point. So if you put in x equals 0, you get 0 over 0 minus 1 is greater than 0, minus 6 is greater than 0. So where the 0 is, that will not be true. So more than likely, it'll end up being here and here. But we're just going to double test that just a little bit more, just to be sure. So let's try now something that is in, say, there. So if you put in x equals 2, you get 6 over 2 minus 1 is greater than 2. So 6 is greater than 2. Yeah, that's true. Let's just test. So we've done that. Test there. So you put x is -3. So go 6 on -3 minus 1 is greater than -3. 6 on -4 is equal to -3 on 2 when you simplify that. And that actually is true. -1.5 is bigger than -3. So that's why you've got curve there. So you've got to now write your solution. So the old way you go x is less than -2 but not equal to it, and x is in between 1 and 3. But we're going to use the interval notation. So that would be -∞ -2, and it's not equal to. That's why I'm putting that curvy bracket. And then it just goes 1 and 3 in a curly bracket, and that will be your solution.